Hello guys, David's here. Today we're doing comfortable cows. This is the February contest silver. So I did all of the open contest. So that was the March one, and I guess I'm just gonna do February. I'll do all of 2021. We'll see. So this is kind of how it works. So go over this. Okay, so basically, let me erase all this. It's being laggy. Okay. So how this is gonna work is Farmer Noi, I'm just gonna say Noi, I don't know if I pronounced that right. Pasture can be regarded as a 2D grid of square cells, so kind of like this. And so a cow occupies a coordinate, and it's said to be comfortable if it's adjacent to exactly 3 other cows, right? So you don't, unfortunately in this case, we don't want comfortable. So what Farmer John does, he can add initial cows to reach to 4, which is 1 above 3, because the maximum amount of like cows adjacent to 1 cow is 4, because there's only 4 different areas, north, south, east, west. And so once like the cows hit, 1 cow hits like a comfortable mark, which is 3 adjacent, he'll just add the 4th one. That's kind of how the strategy works. And so he wants to add additional cows until no cow is comfortable. So originally the coordinates will go from 0 to 1,000, but what's annoying is it can go negative or even over 1,000, so they don't have to be in the range, which is pretty annoying. For each I in 1 through n, please output the minimum number of cows needed so that no cows are comfortable, until no cows are comfortable. Initially, the pasture is 1 through I. So yeah, you kind of want no cow to be uncomfortable, or no cow to be comfortable. So I'll kind of just like, I'm gonna have a little bit of like the graph on my screen and a little bit of the graph on here. Hopefully it won't lag too much, but the idea is, so let's start with 0, 1. So 0, 1, sorry if the graph is not looking good. If you have OCD, I'm sorry. 0, 1, and then 1, 0. So far none of these are comfortable because this guy has 0 adjacent squares and this guy has 0. 1, 0. Oh, I mean 1, 1. So this is 1, 0, this is 1, 1. And then 1, 2. And then now we get our first comfortable guy. So I'm going to mark in red the additional cows. So remember, this was 0, 0, 0. No cows will need to be added to have any comfortable cows. And since we found 1, we have to add 1 more. So that's this guy right here. And then after that, 2, 1. So that means this gets filled. So now we're back to having no, they're all uncomfortable, so no comfortable cows. That's why it goes back to 0. And then 2, 2. So 2, 2. Still no comfortable cows, all good. 3, 1. So 3, 1, we go 1, 2, 3, 1. And we get another comfortable cow. So this guy right here. And yes, yeah, that's the extra one right here. 3, 2. So 1, 2, 3, 2. So looks like we get another one as well right here. And notice that we keep this one too. That's why it increases to 2, because still this is uncomfortable. And in this case, when it went back to 0 right here, the next number it filled took the place of the needed, or the red circle. Yeah, basically the idea is you count how many red circles there are, and the red circles symbolize the additional cows needed to make everyone uncomfortable in that sense. And so yeah, and then finally at 4, 1, this does a little crazy. 1, 2, 3, 4, 1. So we got this guy who's uncomfortable. And then all of a sudden this guy, who is added because of this guy, becomes uncomfortable as well. It's here. And so we have 4 in the end. And if that was a little complicated to understand, just remember like imagine like Farmer John or Farmer Nohe is adding cows, and once a cow gets comfortable, he just adds another cow, and so it keeps on going until like every cow is satisfied or every cow is uncomfortable. Kind of makes a square for some reason. I mean, yeah, I guess it is possible to count like the square, but that's kind of just complicated for no reason. Yeah, you'll also notice that when cows are uncomfortable, they'll make this square. I think that's probably a possible solution, but that's still pretty hard to implement. And you would have to know like what happens if there's like multiple squares, like maybe one square over here, and you'll notice that 1, 2, 3, 4, 5, 6, and that's just like too hard to implement. So the solution I came up with was kind of like this. Gosh, do I have to? Okay, I have to erase everything too, which kind of sucks. But you'll get used to my ugly lines. Okay, so back to here. We'll start from the beginning again, and so what we'll do is we'll take this guy, and we'll check if we'll count the amount of. Actually, it's better just to look at the code, to be honest. Yeah. So if you notice, we're doing a DFS. Yeah, that's important. That can also be known as like flood fill, like because you're DFSing over like a graph of sorts. But I would just say this is just normal DFS. So don't worry about this notation if you don't know what I do, but this is input. This is from Benji if you want to steal that from him. This is a 2x2D matrix of 3010 to 3010. That was kind of like the number that it still didn't have memory limit exceeded, but it fit like the parameters, and it fit so that like every additional cow was fit in, so it was fine. So a 2D vector, this is a vector of pairs or a array list of pairs if you're using Java. So basically like a dynamic array of pairs. And so this is the first element, the second element. And so first I'll check if it already is placed in there. So you'll notice that like when I add this is a good example. So I'm right here. So right now I'm on the fourth one, right? So I'm about to place 2, 1. I'm about to place 2, 1, right? So you'll notice from the points before, the coordinates before, it leads to an uncomfortable or a comfortable cow, which you have to add to. And when you go here, right, it replaces the 2, 1 replaces the red cow, and it deletes it by 1. That's why it decreases. So the only way to decrease your answer oh yeah, you'll notice that because there's 9 numbers, it's like you slowly add your numbers over time, or add your cows over time. That's why. And so back to the idea, the only way to decrease your answer is to already have a cow or a red spot on there, if that makes sense. Like just like this spot already had red on it, I'll just add the cow there because it's taking an additional cow, if that makes sense. Yeah. And so we'll go into the details and nitty-gritty. And so this is the part, this plus 1502 is just to make it so that we account for negative numbers. It still keeps like x, like if I print it out as just xy, it'll still output the normal xy area. It's just that it helps account for negative numbers. Like I said earlier, that's kind of like a strategy. Just go in the middle, you'll put like a large array set, so 2 times n required, and you'll get like half of it to be negative and half of it to be positive. So yeah, and so here I just check if it's, so this check function, what it's kind of like, its goal is just it returns the required amount of additional cows needed to make every single cow uncomfortable. And so if there's no cow there, so this just like this just checks whether it's equal to 1 or 2, g this part. And if it's equal to 0, or if it's equal to 0, it just skips the if statement. If it's equal to 1 or greater, it just operates that if statement. So yeah, so I basically okay, back here. I basically check if this already has like a cow on it, and if it does, I check that what is it gonna add, or what additional cows are needed to fit this guy. Same deal with all 4 directions, and you also want to check the original added coordinate as well. Up here, so what we'll do here is yeah, so this is just to translate towards the graph. It's still going to be x and y, it's just it translates, so like I said earlier, it accounts for negative and positive values. C, so this just counts how many adjacent cows are there, including additional. And so if it's equal to 3, that means we have to add a cow. So we have to find which cow it is. This is kind of annoying to implement because it's kind of just copy paste. But if it's like, I don't know, the north cow, it fills it in and it changes this. And so A and B kind of represent the different, like it's a way so that it counts all possible directions, like all possibilities that if the additional cow, because there's only one additional cow, since there's only 4 possible areas, it just allows it so that you can account for every single additional cow. There's probably a better implementation on the solution side, or the editorial for USACO, but whatever. And so then I'll just DFS to make sure, like, to check if every single cow is comfortable or not. And I also have to check itself as well, just to make sure, because there is like a case where you could like surround yourself with cows. If that makes sense. But yeah, it's kind of annoying implementation. But just know that there are only 5 possibilities to having a comfortable cow. It's the north, south, east, west, and it's south. That's kind of the main point. Yeah, and so this answer variable will just keep track of the required additional cows, and yeah. Let's just look over the editorial. Why not? I think I implemented this pretty badly because you can tell how slow it is. Oh my god. But it still works somehow. The memory is quite a bit as well. We'll take a look. I did peek at it earlier. It was a long time ago. This was by Benji. Wow. Yeah, so same idea. So you check whether it's n x plus y, and the 4 directions. Yeah. Additional notes. Oh, yeah, just make sure that 2000 ones. 1,500. Okay. Oh, he does BFS. Interesting. Okay. What does reevaluate do? Poop. Oh, reevaluate. Interesting. I think he does BFS. I think his idea is very similar to DFS. It may be hard to understand. If you like Java, you can look at this as well. Interesting. I don't know. But the point is, why am I being so slow? Okay. And yeah, I did really bad on this contest a long time ago. But yeah. So yeah, that's kind of how it goes. I think it's every time you add a cow could be like you have 5 different choices, which could be n to the 5th because you have 5 different choices. What did the editorial say? I have to go back. Gosh. plus grid size squared. Really? No, grid size squared? I guess. I don't know, because like, yeah, I'm not sure about time complexity. Because it could just be constant where it just equals to 0. But the point is, recap, if the additional cow, or if there's already a cow, right, on the square, we know that it's an additional cow because they're not going to add double cows in the input. They're going to not add duplicate cows in the input. And that means, it also means it's a additional cow, so we can just take the additional cow, and that's answer mice mice. We'll just do a quick check, and then yeah, checks the center, which is the current point on the graph, and the north, south, east, west. So yeah, that's kind of it. I'll submit it one more time just for the fun of it, and I'll probably do the other problems very soon in this contest. Da, 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 da. Come on, baby. It's also 1 a.m., so I'm a little weird right now. Yay, got it, cool. So yeah, that's kind of the end of the show. Hopefully